So in this video, let us discuss about the derivation of lens maker's formula. For that, let me consider a biconvex lens or double convex lens. It will be somewhat like this. Let mu2 be the absolute refractive index of the lens and mu1 be the refractive index of the surrounding medium. Clearly this will be denser and the surrounding medium will be rarer. Okay. Now I have to draw the ray diagram for the image formation through the double convex lens, and this part is very important. So this is the double convex lens. So every double convex lens has an optic center. Let me mark that as O dash, and through the optic center we have a principal axis. And let me place an object O in here, and the light from the object first reaches the first surface. This is the first surface and this is the second surface. And let me mark this point as P. At the point P, it will undergo refraction. So before that, I have to draw the normal at the point P. Since this is the first surface, its center will be, when you extend this, it will be a circle. In 3 dimension it is actually the sphere, but in 2 dimension it is a circle. So its center will be here, somewhere here. Let's mark that as C1, the center of curvature of the first surface. And for a circular or spherical figure, center of normal always passes through its center of curvature, or normal and the direction of radius are the same. So this will be the direction of the normal. And by the property of refraction, when light travels from rarer to denser medium, it bends towards the normal. So the light will take a path like this. Okay, so an image I dash is formed in here. But we have a second surface, that is this curvature. We have a second surface. Let's mark that point as Q. At Q also it will undergo refraction. And for the second surface, this is the, when you extend, the second surface will be here. So its center of curvature C2 will be somewhere here. So for the second surface, the normal will be like this. Okay. So at point Q, it again undergo refraction. Now it is from denser to rarer medium, so it bent away from the normal. So an image final image is formed. Final image I is formed in the rarer medium. So it will undergo 2 refraction. Now I have to mark the different distances from the optic center. So let me draw a mean line through the optic center, so that every measurement is taken from this mean line. So the distance of the object O from the mean line, we usually take that as U. Optic center distance from optic center to C2 is the radius of curvature of the second surface. See, this is the second surface. So its radius of curvature will be here. And for the first surface, its radius of curvature is R1. That is distance between O dash and C1. And this distance is, let me take that as V dash. That is the image formed for the first surface. And the final image is formed at V, at a distance V. This is V from the optic center. So O dash I is V. Clear? Now this one is the radius of curvature. Okay, that is up to length C1, and up to I we have V. Clear? Now we have to consider the 2 surfaces separately. So consider the refraction at the first surface. We already derived an expression when light travels from rarer to denser medium for a spherical surface. If you have any doubt, you can go back and check the video. It's under the title Refraction at Spherical Surface. I'm not deriving that expression again, but I'll give you a shortcut how to remember this equation. See, the light is traveling from rarer to denser, right? Rarer to denser. That is from first medium to the second medium. And we know the refractive index of the rarer medium as mu1 and the refractive index of denser medium is mu2. Now the shortcut is, first you take the right side, that is it is like this, the refractive index of the second medium by the distance in the second medium. See, for the first surface the image is formed here, I dash. Okay, so its distance is v dash minus first refractive index of the first medium by the distance. The distance in the first medium is u. We are actually talking about the first medium, okay. So u. On the right hand side, you take this in the same order, that is mu2 minus mu1. Now who is responsible for the refraction? The first surface. So the radius of curvature of the first surface. So that's equation number 1. Now consider the refraction at the second surface. Consider the refraction at the second surface. Second surface. Now see, for the second surface, see this I dash has a peculiarity. For the first surface, this acts as the image, and for the second surface, it acts as the object. So we call this as virtual object. So this I dash acts as the virtual object for the second surface. Now remember, this I dash is actually formed inside the denser medium. See here, the refraction is from light is traveling from denser to rarer. Okay. So in the first case, let me draw that here again. Listen this part very carefully. Now this is the refraction at the first surface. So this is the denser part. This is the rarer part. So this is the object and I dash is formed in the denser medium. Okay. So the distance, this I dash lies in the denser medium. And now it is moving from denser to rarer. And we got a final image I. Okay. Now back to our, this is not the correct diagram. I just represented that for your understanding. Okay, rarer to denser, then denser to rarer. O in the first medium, I dash in the second medium, and I in the first medium again. These two are the first medium, and this one is the lens. Okay. Now back to this one, denser to rarer. We took the denser medium as refractive index as mu2, rarer medium as mu1. Now always take the right hand side first. Refractive index of the second one by not second in the right hand side, on the right hand side, mu1 by distance in that rarer medium, distance in that second medium. See, light is moving from here to here right now. So the distance in the rarer medium is actually the final distance of the final image. Okay, I. So V minus now the first medium mu2, the first left hand side, mu2 by the distance in the denser medium is the distance of I dash in the denser medium, that is actually V dash. Okay. Now take the same order, that is mu1 minus mu2 divided by R2. Clear? Now, is that clear? Now we can add these two equations, equation 1 and 2. So when you add equation 1 plus 2, first add the left hand side. So mu2 by V dash minus mu1 by U is plus mu1 by V minus mu2 divided by V dash. The left hand side is over. Now the right hand side is mu2 minus mu1 by R1 plus mu1 minus mu2 divided by R2. Okay, now you can cancel this one. Simplifying, you will get let me write this part first. Mu1 by V minus mu1 by U is equal to mu2 minus mu1 by R1 plus, if you take the negative out, you will get mu2 minus mu1. This equation becomes reverse. Okay, and this minus and plus will become negative again. Okay, so let me erase this and this part become negative. Minus and plus will become minus. And if I take mu1 out, mu1 times 1 by V minus 1 by U. Here the mu2 minus mu1 term is common, so that I can take that out. Mu2 minus mu1. Now what left is 1 by R1 minus 1 by R2. Now take this mu1 to the right hand side. So 1 by V minus 1 by U is equal to mu2 minus mu1 upon mu1 into 1 by R1 minus 1 by R2. Now remember, we have 1 by V minus 1 by U is equal to 1 by F. This is called the thin lens formula, where F is the focal length. So this part become 1 by F is equal to, I can divide each term with mu1. So mu2 by mu1 minus mu1 by mu1 into 1 by R1 minus 1 by R2. So this will be 1 by F is equal to mu2 by mu1 is actually the refractive index of second medium with respect to first medium, minus this will become 1 equal to 1 by R1 minus 1 by R2. So this is the final expression, and this expression is called lens maker's formula. Clear?